Welcome to Methamphetamine. Today we're gonna do the integral of sine of Lnx over Lnx from 0 to 1. And if this integral without the upper limit and lower limit, and that means if this integral is an indefinite integral and this integral is a non-elementary integral, so it cannot be integrated. However, this is an what's that called? Definite integral, and this integral actually converges. So how can we do this? Whenever you see a definite integral, we try to use many methods, like using this Feynman technique. I would like to use Feynman technique in this part. I want to get rid of the Lnx in the denominator, right? Because Lnx, something over Lnx is always hard to be integrated, you know. So let me just use our Feynman technique. Let R of A is equal to some functions, include A. So we want to produce the extra Lnx to cancel out. So what function can we put right here? So I would like to put sine of A Lnx. Like put A inside the sine. So Lnx dx. I haven't checked if you put x power of A in front. That if this is I of A is equal to this, you can also produce the extra x, like x power of A dx. And if you differentiate both sides, you get no, we don't have an A here. A, and this is Lnx. You can produce the extra Lnx, and then Lnx, 1 over Lnx stay the same because it's a constant in the A row, and then differentiate this, you get just stay the same. No, this entire is just a constant in the A row. And then x power of A stay the same. However, x is a constant in the A row, so you need to multiply by Lnx. Here's the formula, dx. And then cancel each other out, you get x power of A, let me write in front, x power of A times sine of Lnx dx. But can we integrate it? Yes. I put this answers in Wolfram alpha, it actually give me the answers. However, whenever you do it and integrate it, and then we're gonna figure out what's the constant. So how can we figure out what's the constant though? Can we choose x is A is equal to 0? It's just the original. A is equal to anything, just doesn't help us at all. So don't do that. Don't do that. So because when A is equal to 1, it's just our original. We cannot use another numbers either. So we cannot choose this. We do not know what's the solution of this, what's the answers of this. So Lnx over Lnx from 0 to 1. So differentiate both sides, you get I pi of A is equal to 1 over Lnx is a constant in the A row, stay the same. And then differentiate this, you get cosine of A Lnx, right? And then don't forget about the chain rule. You're gonna multiply by the derivative of inside, And the Lnx is a constant in the A row, you get just Lnx here. So this Lnx and this Lnx, they cancel each other out. So we're gonna integrate cosine of A Lnx dx from 0 to 1. Now, how can we integrate this though? Cosine of A Lnx going from 0 to 1. You can use up, let U is equal to A Lnx and then do more work. But it will be too hard. I think it's a little bit too hard. So here's the deal, cosine and then inside we have a Lnx, and it's really good for us because let me write this integral cosine of A Lnx dx. Let me add another integral like this is I sine times ANX, right? You know what we are going to do? Combine them, you get cosine of ANX plus I sine of ANX. Just combine the integral like that. So for cosine of something plus I sine of something, it's just our Euler's formula says this is equal to e power of I times something, like a times NX, this, like that. So here's the deal. I would like to put IA into the Ln, use the power rule just. This is the power of Ln, you can put it inside. Just get e power of Ln of x power of e power of Ln of x power of IA. Once you put the IA into the power, just change it into the power of x. You can just cancel e and Ln each other. So far, you're gonna integrate x power of IA going from 0 to 1. And the IA is just a constant in the x world. So far, just add 1 to the power divided by a new power is the same as 1 over IA plus 1 multiplied by that, right? So over, you're gonna evaluating from 0 to 1. So far, put 1 into it. 1 power of anything, just 1. Just 1. Just so far, 1 over IA plus 1 multiplied by that. That 1. So far, you get here. It's kind of messy. But okay. Let me erase it. Just 1 over IA plus 1 multiplied by 1, right? So this, and then subtract, and then 0 power of anything. Just consider this 0. So far, you just get this. However, though, we add this integral each other. We have to, by comparison, what's the answers of this? So 1 over IA plus 1 isn't enough for us to compare the answers to each other. So here's the deal. 1 over IA plus 1. I don't like to be on the bottom. I want to be on the top. So let me just multiply by the conjugate. This is a really common method. Conjugate of this is IA minus 1. IA minus 1. So over the denominator you get this square minus this square. But the formula was a plus b times a minus b. So you get IA square, this entire thing square minus 1 square. So far, this I square is 1, negative 1. So you have a negative, and then a square is stay the same, and then 1 square is 1. And then on the top you get IA minus 1. Like this. So over, you see what happened next. Let me just factor out the negative, and then you can switch the order, right? By the negative, so you can get 1 minus IA over a squared plus 1, right? So you can split to 2 different answers. So you can split to the real part and the imaginary part. You get 1 over a squared plus 1 minus a over a squared plus 1 I times I, right? So here's the deal. We can compare these 2 answers to each other. Here's the deal. Look at this integral. Both of them without, just consider this integral and this integral without the I. Both of them are gonna be real. The answer is gonna be real. So over I times my real numbers. So over, you know this real, right? So I times real is this answers to this, right? Of course, negative a over a squared plus 1 times I is the answers of this. And then 1 over a squared plus 1 is the answer of this. Just really cool. So this, let me just erase this. So over, you get this, right? You get this answers is equal to 1 over a squared plus 1. And this is really cool because we can integrate both sides now. So let me write here, I prime of a is equal to 1 over a squared plus 1. Integrate both sides, you will get I of a is equal to 1 over a squared plus 1. Integrate it in the a row, you get inverse tangent of a. But don't forget about the constant c, because we are talking about the indefinite integral, right? So over, we gotta figure out what's the constant. So I of a is equal to inverse tangent of a plus c is also equal to that. So we can do this. This is equal to this. So over you get this sine of a ln x over ln x dx. So over, what numbers should we choose? So over, let me just choose a is greater or equal to 0. Always, I don't want a is a negative number, and sometimes a is just greater than 0. And if a is equal to 0, that integral will not be converges. So just for in this situation, if a is equal to 0, right? Let me pick a is equal to 0 in this point. So inverse tangent of 0, you get 0 plus c, and the integral of sine of 0 times ln x, and then consider this just 0 over ln x is just 0. The integrate 0 from 0 to 1 over, because 0 doesn't have the area, so over c, our constant is just equal to 0 like that. So over I of a is just equal to inverse tangent of a, and then our original integral just 1 times ln x, our a is 1, right? So over this integral, let me write here, sine of ln x over ln x dx is just equal to inverse tangent of 1. Inverse tangent of 1 it actually have the form like pi over 4 like that.